Today we're going to be taking a look at the next video in our IoT series, which is to put together an ultrasonic sensor demo using an Arduino and a Sqwidnet board, and an ultrasonic sensor. Quickly, just to recap what we've done previously to get us to this point. So firstly, we started off with an IoT description, just defining what the Internet of Things is. We then just used it as an embedded system and did a blink tutorial, so no internet connection, and then the Sqwidnet tutorial, which involved internet connection. Now we are moving to a more complex kind of architecture and example. We are going to be looking to use a glass of water and detect the distance between an ultrasonic sensor and the level of the water in that glass, and then transmit that data over the internet via the Sqwidnet board, as we've done previously, but this time it's meaningful data, not a hard-coded hex value. And then it still goes to our same application, which in my case is hosted on Roku, and then we're still storing it in the same MySQL database. So if we just look at the flow of the data, the basic, where it all starts actually is ultrasonic sensor emitting sound waves that will bounce off of the water level, and then return to the sensor, transmit that data over the internet to the app, and then finally to our database. Now we're going to have a look at the parts required to actually set up an ultrasonic sensor with an Arduino, and we're going to still be using the Sqwidnet Unashield. So yeah, we have our Sqwidnet Unashield already connected to our Arduino Uno board, and we've got the power cable in there with the USB ready. We also already have our breadboard and our ultrasonic sensor all ready to go. You can see it's got 4 pins. It's got a VCC, trig, echo and ground, which is the G and D one. And the last thing we need is just some jumpers, and I've got red, yellow, green and black, and you'll see some of them I've already bent the edges. Okay, so the first thing that we're going to do, I'm going to take columns 25, 24, 23 and 22, and I'm going to insert, of the breadboard, I'm going to insert the ultrasonic sensor into those 4 like that, and you can choose any ones you want really. Obviously just don't put it in the positive or negative columns at the top or bottom. And then I'm taking a black jumper, lining it up with the ground pin. So remember, vertical matches, so anything that matches the ground pin vertically is then part of that same path. Then I'm taking the other end of that black jumper and I'm going to put it in positive side. Now remember, with the positives and negatives, unlike what we just saw where they horizontally match with the positive and negatives, unlike what we just saw where they vertically match, positive and negatives match up horizontally. So we're going to take a second black jumper, stick that in there, and they match up horizontally in the negative row. The other end, that little bent end, which I've already bent for convenience, that's what will go into the actual Sqwidnet shield which is attached to the Arduino board. Okay, so the important thing here is just to note again, now when we're putting in the red one for the VCC, it's got to vertically match. If we're not dealing with the positive or negative rows, and we're dealing with the rest. So we've got to have it vertically match. You can stick it in any one of them that vertically match. I'm going to go for that one over there. And then we're going to stick it in the positive side. Okay, I'm going to stick it over there. And then I'm going to take a second red jumper and I'm going to horizontally align that with the other one so that they are on the same path. And the other end I've already bent, and that's going to go into the Sqwidnet Unashield, which is attached to the Arduino Uno. Then for the next 2, the echo and the trig pins, I've just got one long jumper for each, so we don't need to, there's no extra connections necessary or anything like that. So we're just gonna go. We're gonna take this green one, and we're gonna stick that so that it's horizontally aligned with the echo pin. Sorry, vertically aligned with the echo pin, rather, not horizontally aligned, vertically aligned with the echo pin. And then the yellow one, we're going to stick that so that it is vertically aligned with the trig pin. Okay. And then the other ends of those will also go into the Arduino Uno / Sqwidnet Unashield shortly. So there, we've got all four lined up correctly. Now we're going to take the other ends of all those jumpers. Just grabbing there we go. That's the Sqwidnet board that's been attached to the Arduino Uno. So the first one we're going to grab here is going to go into pin. I'm going to use pin 10 over here, and this is the green jumper, which is connected to the echo. So it's important that I remember which ones I'm connecting to which, because it's going to affect my code. And then pin 9, I'm going to put the yellow one in, which is for trig. So it's important that echo is 10, trig is 9. It doesn't have to be that way, but that I must just remember that, because those are the two that I'm going to use in my code when I define constants for my pins. And now I'm taking the black pin and attaching it to G and D, which is ground. So there's two of them. I'm just doing it to the leftmost one, the one that's right next to the 5 volt. And then there it's got that 5V. That's where we're going to put the other end of the red jumper, which is then connected to the positive row, and then in turn to the VCC pin of the ultrasonic sensor. And that's it. All the jumpers are connected. That's everything we need, and we basically have a ultrasonic sensor that's ready to go. We just need to write the sketch, and that's pretty much that. Okay, so now I'm going to show you a basic sketch to test the ultrasonic sensor. So firstly, we're going to include the software serial library again, because in this sketch we are still going to be using the Sqwidnet board and sending this data to Sigfox. So once again, we define our RX and TX pins, and further down over here we set up the Sigfox software serial. I've explained all that kind of stuff, so I'm not going to go through all the Sigfox stuff in detail here. We set it all up and whatnot. I've done that in one of the other videos. So what is important and different to the other videos is we need to define our trig and our echo pin, because this is specifically related to the ultrasonic sensor. If you recall, previously we had hooked up the trig pin to pin 9 and echo to 10, so it's important we get those correct. For this particular implementation, what I've done is I've created a sample size of 60, and you'll find tutorials that I've referenced to get some of this code, but this part is an extension that I made because I found that when you were just taking single readings, you would sometimes get spurious ones, very high readings, and that would throw things out completely. So one option is to take an average over a sample, in other words a mean, but that obviously with the spurious results they still skew it. So a better option turned out to be a median, where basically you take your, in this case, 60 readings and you order them, and then you take the middle one, which gives you the median. Okay, so, and then there's a delay between the readings, just because I don't want to read too continuously and I don't want to pump too much data through to Sigfox. In production you'd even make this higher. So basically what it's going to do is between each of these 60 readings it'll take a 200 millisecond break, and then once it's done all 60 readings, it will then work out the median and it will then send that to Sigfox. Okay, the other important things here, duration and distance, that's what we're going to be calculating. So once we've got the duration, it's easy to calculate the distance. We'll see how. And these distances, this array, is just my entire sample. So I'll basically store 60, work out the median, send that through, empty out the array or like replace it with an x60, etc. Okay, so in setup, that's where we just set up our pin modes for trig pin as output, echo pin as input. I'm using serial and Sigfox. This serial I'm just using so that we can use the serial monitor, so I can show you what's being displayed. Just right here, like sort of in a console on my machine. And I'm just going to print out it's alive when it's set up, so we can see that it's running. Loop is the piece that repeats over and over. And we're going to do a digital, firstly we need to make sure the trig pin is clear every time. So we set it to a low state for just 2 microseconds. That's what we're doing over there. And then we're going to generate the ultrasound wave. We have to set the trig pin on the high state for 10 microseconds, and then we set it back to the low state. So that's what we're doing over there. Okay, and that will then allow us to get the duration. So we're going to read the echo pin, return the sine wave travel time in microseconds. By the way, most of these comments come from tutorials that I've referenced. Some of them are my own comments. So if you find similar things online, yeah, that's where I've taken it from. So using the pulse in function, you have to read the travel time and put that value into the variable duration. Okay, so 2 parameters to pulse in. One is the echo pin, and the other one is, in this case, we're sending through high, so you could send through either high or low. High means that the pulse in function will wait for the pin to go high, caused by the bounce sound wave, and then it will start timing. Then it'll wait for the pin to go low when the sound wave will end, which will stop the timing. At the end of the function, will return the length of the pulse in microseconds. Okay. Now remember that was for it to travel to the object that it's coming in contact with, measuring the distance to, and then back again. So that becomes important when we calculate the distance. That's why this over 2 is here. So that's because if the object's 10 centimeters away, for example, if you didn't have that divided by 2, your result would be 20 centimeters because it traveled there and back, and you only want the distance there. So that's why you divide it by 2. So the reason we use this 0.034 is because of the speed of sound, 0.034 microseconds. So our distance is simply calculated as the duration, which we worked out from the pulsing function, multiplied by 0.034, and that result is then the distance there and back, so we divide it by 2. And that gives you the distance in centimeters. And those distances I saw in my distances array for the next sample index. While I'm still building up the sample, I continuously just increment the sample index. Once I eventually reach the end of the sample, so I filled up all 60, I then calculate the median distance using a function I wrote, and then I'm printing out to the serial monitor what that distance is, and then I send that distance to Sigfox as well. And then I reset the sample index so I can start gathering the next sample. And then between readings, I just have a delay of, I think, 200 milliseconds. Okay, so these functions, I won't go through them in detail, but I've used this sort descending function, which is based on qsort, to help me order the sample, which is used by my find median distance. You see it uses qsort. And yeah, so then what that does is it'll get the median distance, so like the middle one, as I explained earlier. And then the send distance to Sigfox method, that takes in this distance, which will be in centimeters. And I've just constructed it just so we can see it. It's like in the format data, then like a bracket thing, and then the distance, like 50 or whatever, and then centimeter, and then close the brackets. Now, as I mentioned previously, so this is where we building up Sigfox, $80 equals, so we always started off. Then we put the data, and in order to do that, I've converted it to hex, because you have to convert it to hex, and I found a useful function online that I've got over here, which converts it to hex, character by character. So I just loop through them and convert them, and then carriage return, and that's it. Okay, so what I'm going to do next is I'm going to actually run this sketch and show you what happens in. Okay, so now we can see that the Arduino with the Sqwidnet board and all that stuff, and the ultrasonic sensor, all that's connected. And what I'm going to do is a quick demo to show you what it does. So we've completed our sketch. Now all we need to do is upload it, which it's doing right now, and it's completed. Now we can have a look at the serial monitor. Going to Tools, Serial Monitor. It says it's alive, which was part of my setup method, and then shortly we should see it give us a distance of like 180 something centimeters, because the ultrasonic sensor over here is just kind of shooting up to my roof. 186, as you can see. Now if I put my hand over it, we'd probably expect about a 5 or 6 centimeter reading coming through shortly. That's still a previous one, because remember it works with the sample size. So obviously most of the sample was still at 185. Let's wait for the next one. Should get a better one. 5 centimeters. Let's increase that to maybe roughly 10 or 12 centimeters. And let's see what comes up. 10. I'll put it really low, almost on top of it. We'd expect a very low reading, maybe 1 centimeter or something like that. 2 centimeters. If I remove my hand, it should go back up to 186 centimeters, because it's shooting back up to the roof. Assuming that I haven't pushed one of those wires in the way. We'll see shortly. No, back up to 125. So there we go. That's a basic ultrasonic sensor test, and now shortly we'll see a bit more of an impressive demo where it picks up water levels. So the last thing that I just wanted to show as well with the ultrasonic prototype demo is, as we saw previously, we were sending data to Sigfox. I just showed you what was coming through on the serial monitor. So just to verify that it actually does come through to Sigfox, we go to the backend sigfox.com/device, and then that's your device details, and then messages, and that takes us to this page in the web interface that you can see, and it shows us all the data that's been coming through. Is a timestamp, there's the hex value, but this is just to show some of the different values coming through. So if you recall, the format that I was using always started with data and then sort of angle brackets and then the centimeters in there. So we just go to a simple hex decoder and have a look at what it's sending through. We decode that and we should see the values that we had previously. So this was one of the most recent ones, data 186 centimeters. So as we can see, that same one came through numerous times. If we have a look at this one, I think this is the 2 centimeter one. There we have data, 2 centimeters came through. Okay, so I'm just going to do another demo which is slightly more impressive, where we show you how it picks up the distance to a water level, which then is just a small step away from picking up, volumes. So if we have a look at this, we're just going to re-upload the same sketch firstly, and I'm just going to pop open the serial monitor again. So it's alive. And if we have a look, what I have over here is I have a glass of water with a straw in it, and I have my little Arduino, and as you can see, it's outputting still 186 centimeters, because the ultrasonic sensor over here is going all the way up to my roof. Now if I try to hold it without dropping it above this water, okay, this will give us like a calibration, I suppose. Let me just shift things around a bit, juggling a few things here, so let's see how this works out. So it tells me about 5 centimeters. Let's have a look what happens next. Still says 3 centimeters now, so let's use that as our calibration, and I'm going to attempt to show you the water level dropping as I slowly suck water out of the straw. So there, I've consumed a bit of water. Let's see if the distance has changed at all. The last one was still 3. Remember, it's got to get a whole new sample. Let's see if that's increased at all. We'd expect the distance to be increasing slowly as I drink the water. Still on 3, let me drink more. Four centimeters, so it is increasing. Let's drink more. It's gone up to 5 centimeters. You can see the water level is continuing to drop, and as it's doing so, the distance now has increased to 7 centimeters. We now have 8. Drink some more out of it. Still at 8. Drink more. See the water levels getting nice and low now. 10 centimeters, and let's finish it off. And it's more or less finished. Let's see what it tells us now. There's 11. Let's give it one more go. Water's done. What does it tell us for the next sample? Median is 12. And that's probably where it's going to stay. So, yeah, as you can see, I haven't moved the ultrasonic sensor, and it just continues to give us a reading of 12. So it went all the way from, the first one was 5, and then I shifted my hand slightly down, and 3 was kind of the initial calibration, and it's gone all the way from 3 to 12 centimeter distance. So you can see that actually it is able to pick up water levels, which is pretty cool. And that is that. Thanks again for watching another one of my videos in the IoT series. I hope you enjoyed it, and as always, hopefully found it useful. And please subscribe to my channel if you want to see more videos like this.